Hello and welcome back. In the last few videos we talked about how to factor quadratic equations. We went through methods of factoring simple trinomials and complex trinomials and using difference of squares, and in this video we're going to see the purpose of that, or at least one of the main reasons as to why we went over those factoring methods. So why don't we just start with a simple trinomial over here, y is equal to x squared plus 6x plus 8. That is a quadratic equation, and we are going to factor it the way we normally would. So I will color code these two numbers, and then we need two numbers that add up to 6 and multiply to 8. So we know that 1 and 5 add up to 6, and we know that 2 and 4 add up to 6. We will multiply each of these pairs of numbers. We have that 1 times 5 is equal to 5, and we have that 2 times 4 is equal to 8. So the numbers that we need are 2 and 4, because 2 and 4 add up to 6 and multiply to 8. So we can write our expression bracket x bracket, bracket x bracket, and then we can put plus 2 and plus 4, because those are the numbers that we established. And now that we have successfully factored this quadratic equation, or simple trinomial, I will point out to you that we have our equation in factored form. So by using the method of factoring, we converted our equation from standard form to factored form. And one of the reasons why it is normally of interest to convert to factored form is because it makes it a lot easier for us to sketch a parabola. Normally, if we were to sketch a parabola using standard form, we would have to sketch a table of values and then try to guess where the vertex is, and it would all turn out to be very tedious. If we use factored form instead, we'll find that it is a lot easier. So the point of factored form is that it allows us to get the x-intercepts very easily. We know that the x-intercepts are the values of x where y is equal to 0. We know that if a point is on the x-axis, it has to have a y value of 0. So what we do is we set y to 0, and we ask ourselves, what values of x will give us y is equal to 0? Or what values of x will satisfy that equation? In order for that equation to be satisfied, we can either have that x plus 2 is equal to 0, or we can have that x plus 4 is equal to 0. In order for x plus 2 to be equal to 0, we would need x is equal to negative 2, and in order for x plus 4 to be equal to 0, we would need x is equal to negative 4. So there we go. Because those are the x values at which the y value is equal to 0, we have that our x-intercepts are located at x is equal to negative 2 and x is equal to negative 4. So we can plot those 2 points on the graph, that is negative 4, 0 and negative 2, 0, for the x-intercepts. Okay, once again we have that the x-intercepts are x is equal to negative 2 and x is equal to negative 4. So just like that, we have 2 points on the parabola. Now, why are the x-intercepts very useful? Well, it turns out that for a parabola, if we have any 2 points on the parabola that have the same y value or the same height, in this case a height of y is equal to 0, the point midway in between those 2 points is the location of the vertex. So the midpoint between negative 4 and negative 2 we know is negative 3. And what I'm saying is that if we plug x is equal to negative 3 into the equation, we'll actually get the vertex of this parabola. So I plug it in for x, and I'll have y is equal to negative 3 squared plus 6 times negative 3 plus 8. And that will give us y is equal to 9 minus 18 plus 8, or y is equal to negative 1. So we have that for x is equal to negative 3, y is equal to negative 1, and therefore the vertex is negative 3, negative 1. Once again, we can plot that point on the graph, and then we can connect the points to get our parabola. And we can see that rather than having to sketch a table of values and guess where the vertex is, we have 3 points including the vertex, and we now have a good idea of what the parabola looks like. And that is one of the uses of the factored form of a quadratic equation, and it is one of the reasons why we went through a lot of effort to talk about how to factor quadratic equations. So that is the first example that I wanted to go over. In the next video we'll do another example where we convert a complex trinomial to factored form in order to sketch it on a graph. But for now, as always, thanks for watching.